very clearly from the HARP transmitter. And after that, we had terrible tornadoes and floods and no, I'm just kidding. Global warming.
So, I mean, in other words, now, the fellow that runs HARP was here last year, was he not, at Dayton last year?
I didn't know. No, I was always busy with my kit building booth, so I never get a chance to get away like this.
It was either he was at here at Dayton or he was at Huntsville, and I can't recall which one it was.
Well, I'd like to meet that guy. Again, it's just to create an ionized patch in the ionosphere to bounce a radio signal off of. It's nothing more scientific than that, really.
Well, I mean, there's so much rumor surrounding.
Oh, I know it, but
and not just rumor, but I mean like end of the world kind of stuff going on.
Well, it causes earthquakes, it causes nosebleeds, it causes arthritis, and I think most of it's junk science.
And the thing about it is, there was a book out, and it was called "Angels Don't Play This Harp."
Yeah.
And that book purports HARP to be just everything under the sun.
And do you know, an average transmitter from a television station puts out more effective radiated power than a HARP array. It just HARP happens to do it on high frequencies. They don't do it on really, really low frequencies like some people say to cause earthquakes and stuff. They use high frequency waves. And the energy is minuscule, and all it is, it can ionize the ionosphere, but that's just about it. In fact, sometimes I think when we get into a ham radio contest and a whole bunch of people are getting on the 10-meter band at one time, I think that helps ionize that layer as well and bounce the signals improve when the bands are really active. That's my own theory, though. Doesn't make for interesting broadcasting, though.
Well, now that I got you on the hot seat here, though, you're the one that's actually doing all the testing of all the. I mean, you test everything under the sun that comes into the.
That's correct. Mostly we rely on our membership to ask us and tell us what they want to see in the QST product review column every month. So we will review HF transceivers, watt meters, linear amplifiers, amateur radio accessories. We review antennas, but we don't test them. That's because we just don't have a facility to test amateur radio antennas. But we test HF transceivers is the most liked part of product review, and we do a lot of those.
Well, now I guess here comes the question here.
Yeah.
Now we're not going to. I don't want to go into any type of equipment. I don't want to go into any name of any company.
Okay, got it.
But do you ever get stuff that comes in for evaluation, and you look at it and you say, you know what, this is a piece of junk?
Yes.
I wondered about that.
Yes, it does happen.
Do you remember the Gotham Antenna Company years ago?
Yeah, they made a really bad false antenna, something like that. That was before my time at the headquarters. But one of the nice things about the product review process and what I do at the ARL lab is I get to test these, an HF transceiver, for instance, thoroughly. And if I frequently find issues that the manufacturer didn't even know about. And one of the nicest things is we let that manufacturer know right away, long before that review goes to print. And they get to correct that problem. And we report it in our article. Hey, we found this. We contacted the manufacturer. This is their correction that they did. And usually they always fix any problems. If somebody bought an earlier radio with their lower serial number, they'll honor any kind of repair or modification that fixes that one problem that we found in the lab. But again, they fix the problem. And it's addressed long before it goes to print. So we're there to help the manufacturer, not to bag them, but to work with them to help them make their products better. So you people out there that are ARRL members, you get a better product to buy from that manufacturer, and you benefit.
But I guess the question I have is, if you are a manufacturer, let's just say of an amateur transceiver, and you're putting that thing out on the market, and the league comes along and does field testing on the thing, and they come back and say, this thing's got some issues with this, and this, and this.
Yep.
Kind of makes you wonder, has the manufacturer done any testing like that? Have they? Or why haven't they?
Well, sometimes I say to myself, don't they test these things? Like, how could they miss that? And that does happen. And sometimes I think, well, they get us our free testing to test their transceivers. But for the most part, the big manufacturers have some very, very, very good test engineers. And I'm fortunate enough that I get to communicate with these people and have a relationship with them and have an open dialogue. And one of the nicest things is our procedure manual, the methods of how we test our equipment, how we test, let's say, HF radios. That's published on our website. It's a step-by-step procedure. The equipment that we use is explained, the hookup, step-by-step, etc. And I was very lucky. I was visited by the chief engineer of Kenwood, who develops all the HF radios. His name is Toshio Tori. What a nice gentleman. But he visited the ARL laboratory, and he told us that all of Kenwood's engineers in Japan use our ARL procedure manual to test their HF transceivers. So then he explained an error in the procedure manual of one of the drawings, and we all had a good laugh.
You were talking about the testing of antennas. Okay. You can't actually test an antenna then?
You need a very special test range or a special room that looks like something called an anechoic chamber. It has all these like projectiles and protrusions from it to prevent reflections, because that's the hardest part about testing an antenna is reflections in the field or whatever you're doing. It's hard to compare antenna A to antenna B, and there's a lot of equipment involved as well. And then just the test facility costs, understandably, it costs, I understand, $2 million is the figure that's out there. We'd love to have one, but...
Do you get as far as being able to hook an antenna up and actually use it from that standpoint?
Certainly. We review antennas, so the reviewer actually gets to take the antenna, assemble it at home. They can write about how easy it is to assemble, how clear the instructions are. They'll put it up in their yard or on their tower and test it out for a couple months, preferably maybe even during a contest, so they get a really good idea how the antenna does. And then they report about that. And gain reports, well, we can take that same antenna design and put it in a computer modeling software program, and we use EasyNet 5 at the league, and we can kind of look and see what kind of gain the antenna has, although the manufacturer has to provide us with very detailed modeling and information about their antenna in order for us to advertise the gain of the antenna. If you ever look at QST, none of the antenna ads have actual gain figures attached. They may say the highest gain in any Aggie ever. But no. They can claim a lot, but they are not allowed to actually advertise the gain figures of an antenna unless they provide us with some very detailed and specific information.
Well, all this is really interesting. Do you ever test any vintage gear just for the heck of it to see how it maybe stacks up against?
Well, I'm very much into vintage gear. I get on AM. I used to be on 75 meters a lot. I remember it's me, Bob, here. I used to get on the air and still have them all my AM gear with my command sets, my ARC 5 collection. Back 30 years ago, I got on with ARC 5s, and the old timers said, "Hey, listen to that GCM guy. He's running an ARC 5. I haven't heard an ARC 5 since the end of World War II." And I've always wanted to test command sets in the ARL laboratory, and I've been half tempted to do so. But once in a while, I'll get an older receiver in. Like I just got a nice Drake R4C receiver. Was donated to us for a novice station. We're creating a museum at the ARL Laboratory of Technology. And we're going to have a nice display of every single decade of amateur radio set up in the near future. And we got a nice Drake R4C, so I actually brought it into the screen room and tested a few things about it. It doesn't perform nearly as good as the newer radios, but they do a pretty good job.
Well, see, that was what I was going to ask. Because people like me, we all out there in the flea market area, and you're walking around and you're looking at all these old boat anchors, Yeah,
I love it.
You see the Hammerland HQ 170s and the SX 101s.
Yep.
And you see all these old radios, and including the Drake TR4Cs and all that kind of thing. So you're looking at all this stuff, and you're thinking. I mean, you reminisce about the time that you had it, but there's something happens weird, and that is you don't recall how much that SX 101 drifted.
Well, that's right.
You know, and of course, now there's one you don't ever forget. If you ever owned an ICO 753 tri-bander, you know, that was, I mean, that had to be the driftiest radio that ever hit.
That's right.
You know, I mean, I've never seen anything drift like one of those. I was actually tempted to try to put a clock drive on the PTO to see if you couldn't just spin it slow enough to keep it.
Well, all of us are very nostalgic about radio. We all have sweet memories, so we kind of block out all the bad things of the past and remember the good times.
But anyways, you walk through the flea market and you look at all these things, and I don't think you really realize how advanced the new radio equipment is until you take and hook up one of those old rigs and turn them on and start listening. And, you know, I mean, I don't know. Can you think of, is there anything vintage you can think of that you could hook it up and you would say, well, you know what? This thing performs every bit as good as anything out on the market today.
Well, let's clarify that a little bit. Now, you take some lesser expensive transceiver, and I'll throw out a couple. There may be a transceiver that, let's call it the ICOM 718 and the Yaesu FT 897, and something like that. Now, they don't have roofing filters in them. They still have DSP, and they do a great job with filtering. And a lot of those bottom-of-the-line, lower-end transceivers perform better than some of the best of the old days. Now, I own a Collins-built R390 receiver from the 1950s. Beautiful, beautiful, beautiful receiver. But how does it do in the third-order IMD department? Or how does it block adjacent close signals? Well, the newer radios do a better job in that regard. And another receiver that I've owned is the Collins 75A4. Hard to top that radio. But if you ever have a close adjacent signal, did you ever notice the volume drops down? Well, that's because it's called blocking dynamic gain compression. Let me say that again. Blocking gain compression dynamic range. This is when you have a really strong signal that actually will lower the audio of the signal you're trying to hear. And you notice a lot of the old receivers actually do that. But for casual operating, some of these old radios are just totally satisfactory to use. Wouldn't want to try and use them in a contest, seriously, but I would like to use them just to have fun rag chews with people with similar interests. You can't beat it.
So I guess if you were to take a radio, and I'll use this generically, I guess as generic as I can get, but I am mentioning a brand name.
Go ahead.
If you take a radio, like say for the entry level ICOM 718,
yeah,
okay, as an entry level radio, that is an impressive little rig.
It most certainly is.
Okay, now you take that and compare that to a Drake TR4C.
Yeah, well, I don't know all the specifics of a Drake TR4C. That was a good radio in its day. It had some pretty good filters in it.
Or let's just take the receiver section of an R4C. I mean, let's just take, because that's a radio almost everyone is. Yeah,
but you know, the 718 has noise reduction circuitry in it. It has DSP, digital signal processing in it. So it has just advanced technology.